In chemistry, we need to sometimes be able to count atoms. And since atoms are so incredibly tiny, we don't have a way to individually pull atoms out. We can't say, here's 5 atoms. That's too small for us to be able to use. So, but we do need that ability to count the atoms. So what we do is we have a unit called the mole. The mole is a word that symbolizes a number, similar to how 1 dozen equals 12. We have 1 mole equals 6.02 times 10 to the 23rd. That means that's 6.02 followed by 21 zeros. Remember that this is just a number and that you just have that decimal has been moved over 23 spaces. For our purposes, we're going to be talking about atoms in this unit. But it can also refer to molecules, which we'll talk about in a few units, and it basically represents 6.02 times 10 to the 23rd of anything you're talking about. We also know the molar mass of substances, which is the mass of a mole. Molar representing mole, mass representing the mass in grams. So on the periodic table, the number underneath the symbol that has a decimal, 26.98 grams, is the mass of 1 mole of aluminum. You can look at oxygen, and it says 15.99. You can look at carbon, it says 12.00. So whatever you're looking at, whatever element you're trying to find, look at the mass, look at the number underneath the symbol on the periodic table, and it'll tell you the molar mass. That's the mass of 6.02 times 10 to the 23rd particles. So these are our 2 conversion factors, we say. It's the 2 relationships that we know equal 1 mole, and that's what we're going to use to solve these problems. Keep these in mind. These are your best friend. The first one is on the star chart. The second one you just have to know. Let me work an example for you. What is the mass of 6.0 moles of carbon? Get my right color. Let's get black. Alright, so we're going to set this up. We're looking for the mass. Alright, that's going to be measured in grams. We're given 6.00 moles of carbon. So we have X grams because we're looking for mass. What is the mass? We don't know how many grams there are, so we're going to say X grams. We're going to put that over 6.00 moles. Now on the other side, come over here and put your same units. Okay, so we have grams to moles is the relationship we're looking for. So we know that 1 mole is equal to 12.0 grams. That's from the periodic table. That's where I got to 12.0. I rounded it to the tenths place, and 1 mole is 12. So now I'm going to cross multiply across. So I'm going to say 6 times 12 divided by 1. Cross multiply and divide. That gives me an answer, 72.0 grams. That's how many, that is the mass of 6 moles of carbon. Alright, another example. We're going to set this up the same way. What am I looking for? In this case, I'm looking for moles. Oh, I got to set my pointer back. Looking for moles. And I'm given 50 grams of sodium. So I'm going to say X moles. And then I'm given 50 grams. So I have moles and I have grams. How many moles and how many grams? This says sodium, so I'm going to look up Na on the periodic table. It's on the far left. And when I look that up, I get 1 mole, and then I need the molar mass, and that's going to be 6.9 grams. I'm sorry, that is completely wrong. I'm going to get 23.0 grams. I accidentally pulled the number off the lithium, which is right above it on the periodic table. So make sure you get the right element when you're doing these. So here I'm going to cross multiply 50.0 times 1 divided by 23.0. And when I get my calculator out, I'm just going to do 50 times 1 divided by 23. And I get an answer of 2.17 moles. Alright, another example. Again, set it up the exact same way. I'm looking for atoms. I'm given moles. X atoms is 2.5 moles. So now I'm going to come over here. I'm going to say atoms and moles. And my relationship here is I know that 1 mole of anything is 6.02 times 10 to the 23rd. So now I just cross multiply and divide. 2.5 times 6.02 times 10 to the 23rd divided by 1. I put that into my calculator. 2.5 times 6.02 second E 23, and that gives me 1.5 times 10 to the 24th. And that unit is going to be atoms. So I know that 1 mole equals 6.02 times 10 to the 23rd atoms. How many moles equals 2.5? And here's my answer. Now here's one with lithium. What is the mass of 1.25 times 10 to the 24 atoms of lithium? So here I'm looking for grams and I'm given atoms. So I'm going to set this up the same way. X grams 1.25 times 10 to the 24 atoms. If you don't write your units in these problems, it makes the problems a lot harder because the units tell you what numbers to use. So we're going to come over here, we're going to say grams and atoms. Alright, so my relationships that I'm going to use. I know 2 relationships here. I know how many grams are in a mole, and I know how many atoms are in a mole. So this example shows you that anytime you have the unit G, you're going to get the number off the periodic table. So in this case, it's going to be 6.9 grams because that's what's underneath lithium. And then anytime I have atoms, I'm going to come in, I'm going to put 6.02 times 10 to the 23rd. All right, grams is always going to be the molar mass. Atoms is always going to be 6.02 times 10 to the 23rd. So now I'm going to cross multiply and divide. So I have 1.25 times 10 to the 24th times 6.9 divided by 6.02 times 10 to the 23rd. And I'm going to put that in my calculator. So I get 1.25 second E 24 times 6.9 divided by 6.02 second E 23. And here I'm going to get 14.3, and my unit is going to be grams. And that is my answer. All right, let's go back to here. These are your two key conversion factors. These are the two things that tell you the numbers you need to use to work these problems. All of the problems are worked exactly the same. You just write down your units and use the conversion factor. Hope you find this helpful. If you need some additional help, please come see your teacher.